Well, thank you for returning from lunch. That was a nice break. So far, we have talked about 7 assumptions built into the light travel time challenge. We talked about the first 4 so far. We saw that the first one seems to be reasonable, that the speed of light has not changed throughout history. The second one, however, is demonstrably false. The one-way speed of light is not absolute. We don't know what it is because it's unknowable. Furthermore, we can actually choose to use different values for that depending on the circumstances, which means that an absolute challenge for light travel time is not valid. Assumption 3 was that the universe was not created mature. We see how that would solve the problem if it were. Assumption 4, that light has always traveled through space as it does today. If that's not true, if the Lord supernaturally accelerated things, then of course that would solve that problem as well. And we finished by looking at what I call the secular dilemma, a 6-word question. Who remembers what it is? Did the universe have a beginning? We saw how both answers to that question are going to violate physics in a different way, that this causes problems for secular modelers, but not for us, because we know a supernatural creator outside of physics is responsible for the universe. So that catches us up to where we were. Let's proceed further now and explore the remaining 3 of these 7 assumptions. So back to our equation. We are once again going to look at a different aspect of speed, a different assumption built into this equation about speed. We already said that the speed of light apparently has not changed throughout history, throughout time. What if, though, it changes according to location? What if it's variable through space? What do I mean by that? Well, where have we measured the speed of light? All of our measurements of the speed of light have been done where? Here on Earth, which is within our solar system, which is within the gravitational field of our sun, and the sun itself is within our galaxy. What about elsewhere? What would the speed of light be outside of our galaxy? We don't know. We've never measured it there. Now, it's usually assumed that it's the same out there as it is here, but some scientists are questioning this. Relativity understands space-time to be a sort of a fabric, in a sense, in the way that it behaves. We know that a distortion in space-time introduced by gravity, let me simplify the statement. We know that gravity affects the path of beams of light. When light travels by a massive object, it'll actually be bent around that object. Well, what if this same effect would affect not only light's path, but also its speed? Is it possible that light travels more slowly through a gravitational field? More specifically, is it the same in deep space as it is here in our solar system, which again is the only place we've ever measured it? There are scientists looking at this now, and as you can imagine, if light traveled more quickly in deep space in between galaxies than it does here on Earth, then of course that would decrease the time required for light to travel through space to reach us, right? And this is gaining interest not only in the creation community, but secular scientists have actually been looking at this longer than we have. This is called VSOL models, variable speed of light. There are some secular cosmologists who are investigating this as a possibility. Now, their motive is not to explain why the Bible is true. They're trying to solve some problems with the Big Bang model. But my point is, this isn't some fringe idea that creationists came up with. This is actually an ongoing effort on both sides of this debate. So assumption number 5, then, is that light speed is constant across space. If that's not true, then, of course, that would decrease the amount of time necessary for light to get here. So far, we've actually pulled quite a bit out of this equation that wasn't all that clear up front that it was in there, right? You see how there's a lot of assumptions built into this that are indeed built into it, but that you just kind of take for granted. We've questioned distance and we've questioned speed. Can we question time? And the answer is yes. So here's a proposed cosmology by some people within the creation movement. We are used to thinking of creation as happening inner to outer, in a sense. That first there was nothing, then the Lord created the earth, and then the cosmos was created around the earth. What if, from a certain perspective, it happened in the opposite sequence? That the Lord created the outermost galaxies first, and then moving inwards at the speed of light, created the next innermost amount of galaxies, and the next innermost amount of galaxies, and finally the earth in the middle, such that the light from all galaxies in all directions arrived here all at the same time on day 4 of creation week. Now, this was from an earth-bound observer's perspective. On day 4 of creation week, the night sky was empty until suddenly it was full. You would see nothing in the heavens except perhaps the moon and the planets. But then all of a sudden, light from all galaxies arrived from here in all directions. So on the 4th day, everything appeared. So from an Earth observer's perspective, that's when creation of all these objects in the cosmos happened. Now, when talking about this idea, many Christians will immediately have an objection. Wait a minute. You're saying the galaxies were created before the Earth, but Genesis says the Earth was created before the galaxies. Well, Genesis does say that, and that would be true from an Earth observer's perspective. But there's more than one perspective that's valid. And this ties into another idea here, that we want to treat time as absolute. That there's this absolute sequence of time, as shown in Genesis. There's day 1, day 2, day 3, day 4, etc. From a galaxy's perspective, things would happen differently. From the galaxy's perspective, it was created first. The other galaxies around it were. Some of the outermost galaxies wouldn't actually be able to perceive the Earth yet in a young creation, because light has not had time to travel from here to out there. Whereas from an Earth's perspective, Earth was created first. From the galaxy's perspective, galaxies were created first. I hope I'm not losing anybody yet. The point is, depending on where you are in the cosmos, you would perceive things happening differently. And this runs counter to our everyday intuition, because we're used to thinking of time as an absolute thing. But it's actually not. For example, are you experiencing this presentation live this morning? You think so, right? But you're actually not. Light doesn't travel infinitely fast. Sound doesn't travel infinitely fast. There's a tiny fraction of a second for my image and the sound of my voice to go from me to you. You ever think about that? So you're actually experiencing a delayed version of this presentation. Now, in this case, the delay is so small that it doesn't matter, so you don't think about this, right? In astronomy, though, it does matter. For example, when Venus does a transit of the sun, in other words, where that little dot there is the backside of Venus, Venus, once in a while, not very often, but once in a while, will travel in between the sun and Earth, and we see what's called the transit. Can you experience this event live? Well, you'd think so, because you can look up on the NASA site when the next one will happen, go outside and look at it. But actually, it takes time for sunlight to get from Venus's location to us. In a sense, there's a time delay. When you see a solar eclipse, like the annular eclipse that happened the other day, if you got to see that, did you see that live? Or did you grumble and say, there's a 1 second delay between the time the light got from here to there, and I wish I could see it live, but no, I'm watching a movie. No. You treat it as if it's a live event, right? You treat it as happening when you experience it. In similar fashion, from an Earth's perspective, the night sky was empty, suddenly it was full. From an Earth perspective, the galaxies appeared on day 4, so that's essentially when they were created. You're not trying to impose some absolute time scale, because you realize it's different for different locations. And we even the conventions we use. I mentioned earlier that there's supernova 1987A happened in 1987, but if this thing is 168,000 light years away, why didn't we call it supernova 166,000 BC? Well, no. We named it by when we experienced it. So from this perspective then, naming is the wrong word, time-stamping events by when we experience them, an observer on Earth would therefore say the galaxies were created on day 4, because that's when an observer on Earth would first see them and first experiencing them. So that's when creation happened. Now, again, there are other perspectives outside of the Earth, but Genesis is written from an Earth observer's perspective. This is part of a larger idea within relativity that says there's no absolute sequence of time across the cosmos. On large enough scales, and even when velocities relative in different objects get to a certain point, there's no absolute sequence of time. We think in those terms, but on large enough time scales, that's not true. Different observers will experience events in different order, depending on their location. And if you're unsure about that, bring that up during Q&A. There's a little, like a live demonstration I do to illustrate that point. Did anybody get lost in that one? It's kind of hard to explain this. Yeah, people are nodding. The basic idea, just to reinforce, is that according to this proposal, Again, I'm not endorsing or denying, I'm just presenting what someone within the creation community are talking about. According to this proposal, the Lord created outer shell of galaxies first, and then moved inwards, creating more galaxies as he went, and changing his focus, if you will, at the speed of light, so that the first outer shell would be producing light that would be moving inwards at the same time as the next innermost shell was created. So the light from the outer ones is now moving with the light from the inner ones, which moves from the inner ones, etc., so that all the light arrives here at the same time on day 4. So that's the basic cosmological idea. All this business about relative times and observers is to answer the objection that, wait a minute, Earth was created before the galaxies. Yes, that's true from our perspective. From other perspectives, though, people would perceive things differently. Okay, well, again, if you're unsure about this, and bring it up again during Q&A, we'll spend more time on it. But that was the 6th assumption, that we have to use an absolute sequence for ordering events, and that's not true. Back to our equation. Is there anything else we can extract from this equation in terms of assumptions? Yes. Again, we can focus on time. Relativity tells us that there's something called time dilation, where time flows differently for different observers under different conditions. Now, there's actually a couple different ways this can happen. The one I want to talk about is from gravity. Gravity affects time. The deeper you are in a gravitational field, the stronger gravity is for you, the slower time flows for you. And if that sounds like a weird concept, here's another way to put it. Every clock you could possibly build will operate more slowly in stronger gravity. Whether it's a mechanical clock based on spring tension or electrical clock based on electrical, whatever. Every possible clock will operate and tick, quote unquote, more slowly in stronger gravity. So relativity predicted this. For a while, there was no way to test it. Today, it is indeed testable. Let me back up a minute. There's several atomic clocks, for example, in the United States. And these are the most precise instruments we can build for measuring time. There's one in Washington, D.C., the U.S. Naval Observatory, which is close to sea level, and there's one in Boulder, Colorado, which is roughly 1.5 kilometers above sea level. The one at sea level is deeper within Earth's gravitational field than the one in Boulder, by roughly a mile. This one at sea level measures time slightly more slowly than the one in Boulder. Now, these are both atomic clocks. They're both very precise. But yet the one deeper in Earth's gravity measures time more slowly, just as relativity predicts. And this isn't merely a matter of theory and observation. Some of our technology actually has to compensate for this in order to work. For example, the GPS system relies on a precise synchronization of clocks between GPS devices down here and the GPS satellites almost 20,000 kilometers in space. The GPS satellites are farther out of Earth's gravitational field than we are down here. As a result, there's actually a time difference between our clocks down here and GPS up there. GPS actually has to compensate for 38 microseconds per day difference. Time flows more quickly for the satellites than it does for us down here. Not by much, it's a small amount. But if this wasn't compensated for, the clocks would drift out of synchronization and GPS wouldn't work anymore. So my point is, relativity predicted gravity will affect time. That was then confirmed by experiment. And some of our technology today even has to compensate for it. So we know this is a real thing. So why did I bother talking about that? Because in several places in the Bible, it says, "Thus says God the Lord, He that created the heavens and stretched them out." So a number of years back, a Bible-believing physicist named Dr. Russell Humphreys was thinking, if the Lord stretched out the heavens, well, that would imply the heavens used to be smaller. What if, at the beginning of creation, the Lord made everything in the universe in a small, compact volume? If it were a small enough volume, it's possible that the entire universe could have started out inside of a black hole. And I'm showing this dot here represents the event horizon. It's not a physical thing, it's a distance. So in my crude diagram here, if this was everything in the universe, and it was within a black hole, there'd be some distance within which everything inside of it would be inside the black hole, and outside the black hole would be over here. There's nothing outside of the black hole yet. Now, immediately some people say, wait a minute, black holes are pretty weird. Are they real things? Yes, they are real things, actually. This is an artist's conception. It's impossible to see a black hole directly by definition because no light can come out of it. So that's the black thing here. But we can see what's called an accretion disk, where matter is basically being torn apart as it spirals into the hole. And there are multiple examples of this that are now being seen, including one at the center of our galaxy. So although it's impossible to observe them directly, we can observe what certainly seem to be black holes. In fact, at the center of our galaxy, you can see stars orbiting something very quickly. You can't see the something itself, but you can see the stars moving very rapidly, and the only way we know how to account for that is that there's a lot of mass in a very small volume of space doing that, small enough to be in a black hole. So black holes are real, and if the Lord created the universe in such a way that it was within a black hole and then started stretching it out, what would that look like? Well, the material would expand, and in this idea, the Lord is starting to form things from this material. As the Lord continued to stretch, eventually some material would move out of the black hole. At that point, the black hole would start to shrink. And now we have stuff outside the black hole while most of the rest of the universe is still inside, including the Earth. The Earth is still in the middle in this scenario. And this is where it gets interesting, because one of the weird things about black holes is the gravity is so extreme that time would essentially stop if you were within a black hole. So if some of the universe, including the Earth, was within the black hole, where time was essentially stopped or something close to that, outside the black hole, time is flowing normally where the outermost galaxies are. Now the Lord continues stretching, things get bigger. Again, time is flowing outside the black hole while everything's still inside. Time has hardly moved at all. Lord continues stretching, universe gets bigger, black hole gets smaller, until eventually the universe is large enough has moved out of the black hole that the black hole disappears. From this point on, time flows normally throughout the cosmos, subject to local variations like being next to a black hole or something. But overall, time is flowing normally. So now, here on Earth, time is flowing normally, and way out there, time is flowing normally. But what happened before this point? Millions or even billions of years passed out here, while in here passed a 24-hour day. So you see how that can work. Not only does this provide time for light to get from there to here, it also provides time out there for some events like galaxies colliding, which would otherwise seem to require long periods of time. So this is a basic idea behind models of time dilation. Now, I should mention that the physicist who first came up with this has changed his thinking quite a bit. He's bringing other aspects into his model. I like presenting the first one, though, because it's a clear illustration of relativistic time dilation. And you can see how this opens up a lot of possibilities for models of creation cosmology, right? So if time can flow differently in different places depending on something like gravity, then this is another tool in the toolbox, so to speak, for us to build models and answer the LTT question. So that is the seventh assumption in this challenge, that time has always flowed uniformly throughout the cosmos. And we see that there are possible ways in which that wasn't true, depending on how the Lord initially arranged the stuff in the universe. So the overall question of distant starlight, does it disprove biblical creation? The answer is no. You see, of the 7 assumptions, one of them seems to be valid. The other 6 can all be questioned, and at least one of them is demonstrably false. Whoops, 7, not 6. Now, I'm not saying that all of these proposed solutions are correct. It's possible to have combinations of several of them. My point is there's multiple possible approaches to this question that biblical creationists are taking. As a creationist I know said, this is a great time to be a biblical creationist. Not that long ago, people didn't really have an answer to this question, and they had to rely on mature creation or perhaps the speed of light changing. Now you see there's almost too many options, right? We have too many tools in the toolbox, so to speak, and maybe there's other approaches that we haven't even thought of yet. Because ultimately there's many possible solutions to this question. It is not a showstopper for us by any stretch of the imagination. Nor would we expect it to be anyway, because as the Bible says, the heavens declare the glory of God. We would expect that as we explore the cosmos more fully, we would appreciate his glory more and more, and that there will not be unsolvable problems within it. And indeed, there are not. So that's the end of my prepared material. Several people have asked me if I have a website. I do. It's called creationastronomy.com. There's a sign-up form at the bottom of every page for my newsletter. If you like this rather unusual perspective on astronomy, that's available to you there. It's free and only comes out a few times a year, so you won't get a whole lot of spam. As Rob mentioned at the beginning of this talk, I do have a 3-part series on DVD. The first one goes through every planet in the solar system, showing how each one discredits secular origin models in a unique way. A lot of fun, very visual presentation. It's a lot of material there. It actually doesn't even fit on one disc anymore. It's now a 2-disc set. As you mentioned, that one is now sold out, but you can sign up on the list. This one is for all ages. By the way, all my material is for all ages, but this one especially. There's over 500 images and graphics from NASA and other sources, lots of beautiful pictures of planets and moons and all the rest of it. So I've had elementary kids, elementary school age, enjoy this one as well. Volume 2 in that series, which is still available on the table, talks about stars and galaxies. Is there evidence for design in our sun? The answer is yes. Can stars form on their own without a creator? The answer is no, at least not the first generation. Once you have stars, they can interact and maybe make new ones, but where did the first generation come from? Secular modelers actually have problems accounting for the origin of galaxies as well. And what does the size and scale of the cosmos tell us about our creator? So that's volume 2 in that series. Volume 3 is about the universe itself. Where did the universe come from? Is there evidence for a Big Bang? The answer is no. Not only does the Big Bang model not have evidence to support it, there's a lot of evidence against it. In fact, when you take it to its logical conclusion, it has absurd implications, which would tell us that the original assumptions in it are absurd. Because ultimately, what do the heavens declare anyway? Not the glories of the Big Bang model, not the glory of aliens who brought the universe into existence. It declares the glory of our Lord. So I will leave this up on the screen for a moment while I open this up for questions, which I understand we have a few minutes to entertain. Yes, Pastor?
So I basically, just to summarize, what you're saying is often a secularist will say, well, the distance of the stars, they sort of use it as a trump card to defeat the creation argument. But I think what you're showing us is that there are many possible answers that are reasonable solutions to this issue.
Yes. And I also started up by making the point that the secular people have the same problem we do.
Yes.
Although many aren't even aware of it in those terms.
I think that's important.
Yes. Other questions? Yes.
I'll break the ice with a question. You didn't mention it here, but I know you've mentioned it in some other talks, but quite recently the James Webb telescope has shown a lot of things that don't fit the long-age model. Wondering if you could just touch on some of the things that are being found out by that.
How much time do we want to spend on that?
Yeah,
Is the question.
Well, we've got another, but maybe a bit.
Okay, this is all Rob's fault.
It always is, don't worry.
I need visuals, of course, to talk about this. This ties into what I have on my second DVD, problems with star formation and galaxy formation. The James Webb material, of course, is newer. To discuss that, what James Webb is finding, first let's ask the question, let's talk about galaxies for a minute. What is a galaxy? So a galaxy is a system of stars, gas, and dust, etc. We live in one, of course, our Milky Way galaxy, which we can't see. This is just a graphic, but if we could see it from the top, it would look something like this. Now, the Milky Way is a barred spiral. There's a bar in the middle and spiral arms. This is not the only type of galaxy that is possible. Astronomers have this classification system for galaxies. As you can see, there's a bunch of different flavors here. Without getting into details, I'm going to focus on a few major categories. So there's spiral galaxies that have a central bulge and a disk with spiral arms. Lenticular galaxies have a central bulge and disk, but no arms. Elliptical galaxies are round or oval, not much structure within them. And then there's irregulars, which are basically just big blobs of stars. Okay, so if you're a secular astronomer, you want to come up with some kind of scheme for how all of this could have formed by itself. So astronomers, secular astronomers, have this overall idea of galactic evolution, and this is a general view. I'm not going to go into too much detail. But basically the story is dwarf and irregular galaxies formed first, then they combined and merged and made disk galaxies, and then the disks combined and merged to make elliptical galaxies. So this is the basic idea. And it was understood that galaxies would need somewhere around 3 to 6 billion years to form, initially. Now go back about 30 years or so. The Hubble Space Telescope, which was launched in 1990, gave us clarity and a view into the heavens that we never had before. As an example, Big Dipper right here, familiar to many of us, I'm sure. If you can see that little tiny, it almost looks like a line probably from the back of the room, that little rectangle. This rectangle here is that. And within this rectangle here, that little rectangle here is this. So this is the picture Hubble took, which is only this within this rectangle, and the little rectangle is that in the sky. So point is, Hubble can get really good views of stuff that's very far away. And you're probably familiar, well, you might be familiar with some of the famous photos like the ultra deep field, where there's thousands of galaxies in a tiny little speck of the sky. So if you imagine holding up a grain of sand at arm's length, how much of the sky would that block from your view? Not your fingers, just the sand. Tiny amount. Behind that sand, there's thousands of galaxies in all directions. So Hubble gave us this amazing view of the cosmos. Now, from a secular perspective, Hubble can look so far out that we're looking over 13 billion years into the past. Now, again, this is the light travel time thing, right? But from a secular perspective, they want to have a straight correspondence between distance and time. So from a secular viewpoint, Hubble can see so far out, over 13 billion years. This is less than a billion years after the Big Bang supposedly happened. Therefore, from a secular perspective, we should see, quote-unquote, immature galaxies out there. Because remember, galaxies took up to 3 billion years to form. You had to get the dwarfs and then the disks and then the ellipticals. So they expected that the farther out we look, we should start seeing immature ones as galaxies are forming. That's not what Hubble found. This was known as the early mature galaxies problem. The farther out Hubble looked, we kept seeing mature galaxies all the way back. And secular astronomers struggle with this. As this author said, we expected to find basically zero massive galaxies beyond about 9 billion years ago, because theoretical models predict that massive galaxies form last. Instead, we found highly developed galaxies that just shouldn't have been there, but are. Another author said, we're detecting galaxies we never expected to find, having a wide range of properties we never expected to see. We are really amazed. These are the earliest, oldest galaxies found to date. Their existence was not predicted by theory. So right now we're talking about mid-2000s, 2004, 2005 is when a lot of this came out. This was known as the early mature galaxy problem. Now, secular astronomers did have one source of comfort in all this, in that a lot of the galaxies that Hubble was finding appeared to be irregular. A very high percentage of the galaxies were irregular. So although the mature ones that were there too shouldn't have been there, they could at least say, well, there's more irregulars than mature ones, so we at least see some form of galactic evolution happening out there in the distant cosmos soon after the Big Bang happened. Then, in 2021, the James Webb 2021, James Webb was launched. It is a 6.5 meter mirror and can gather more than 6 times as much light as Hubble can. And it has even better performance than Hubble does. For example, this is a photograph, or 2 photographs of the same region. This is the Hubble's photograph, and this is the James Webb. And I'll overlap them here so you can compare. This is Hubble, this is James Webb. You see how much better that is, right? I mean, wonderful, wonderful photographs we're getting back from this. Within James Webb's discoveries are numerous surprises. So James Webb here is taking photographs of stuff that Hubble had already taken photographs of, and finding better detail, as you can see, including a lot of new galaxies, new to us in the sense, because Hubble couldn't see them, James Webb can. Many of these new galaxies are disk galaxies, which you remember are mature, not the first part of the sequence. Furthermore, a lot of the ones that had thought, or that astronomers had thought were irregular, turn out to actually be disks, now that James Webb has given us more detail on them. So not only is James Webb showing there's a lot more disks than astronomers knew about, but a lot of the irregulars that they thought they had, those were also disks too. And again, this is the opposite of what galactic evolution had expected. And so a lot of new papers are coming out. This particular study, one region found 10 times more disk galaxies than Hubble had seen previously in that location. But not only is James Webb able to take better photographs of what Hubble had already taken photographs of, it can also observe it in the infrared and therefore look farther out than Hubble could. And as this quote noted, before the James Webb observed this one particular cluster, astronomers predicted it should find effectively 0 galaxies, but they found several. So James Webb is now able to, and a lot of this is new. I mean, this is coming out almost every month or so. There's new discoveries being announced. But like this photograph here, this galaxy from the Big Bang perspective, which again, we shouldn't accept, but they do. From their perspective, this galaxy already existed just 450 million years after the Big Bang. Remember, a galaxy is supposed to need 3 billion years to form? That's 3,000 million. This is only 450 million. This one's only 350 million. This one here at 380 million, and another possibly at just 250. So lots of discoveries of this coming out, as this article commented. We've nailed something that is incredibly fascinating. These galaxies would have had to have started coming together maybe just 100 million years after the Big Bang. Nobody expected that the Dark Ages would have ended so early. So this used to be called the early mature galaxies problem, and the fact that James Webb has made this so much worse, it's now being called the impossible early galaxies problem. Even some papers being published are using that in the title. Even finding some Milky Way type galaxies where there shouldn't be any because that's supposed to be very mature. This quote says, "We just discovered the impossible." Again, the impossibly early galaxy problem and so on. Now, which model is this consistent with? In the creation account, the Lord made the cosmos to function like a cosmos. We wouldn't have expected to find immature galaxies forming into mature ones, right? Because the Lord didn't need it to make evolution, an evolutionary sequence. He created a cosmos to work, to be functional. So we would expect then, the farther out we look, we're going to keep seeing mature things, quote-unquote mature things, all the way back. So the observations match our expectations, but they don't match secular models. Secular modelers have long since run out of time to make anything cosmologically. If you need 3 billion years to make a galaxy, but we're seeing stuff so close to the alleged Big Bang as only 100 million years, well, you see the problem. So I've actually been expecting, since the Hubble discoveries, I've been expecting the Big Bang people to push back the time of the Big Bang because they need more time. Even though the Big Bang is supposedly a very precise, accurate measurement of 13.78 billion years ago, they're going to have to change it, in my opinion. And there's already some inkling of this. Recently, some researchers suggested adding 13 billion years to the age of the universe, doubling it. What does that tell you about how precise the number was to begin with? You know? Now, this isn't mainstream yet. This is only a few researchers suggesting. But the fact that the suggestion is even possible tells us something about how flexible and pliable these so-called precise numbers are. Yes, question?
I don't get a kick out of the numbers they proposed, whether it's 13.4, 26.7, whatever. Implying a 3-digit number like that implies that they're accurate to within 1%. And that just blows me away how they can be so accurate to within 1%.
Yeah. Yes, question?
If like doubling the age rescues that theory, do we expect to see if they could just see that much further, these young galaxies will start appearing or something? Is that...
Yeah. If they give themselves more time, then they can look farther out and eventually see the immature ones. That's the thinking. Yes, sir?
I'm listening to somebody right now that's making a big deal about the fact that so everything seems to, the galaxies in our Earth goes counterclockwise. Venus, I think Venus and Uranus don't.
Right.
They go the opposite. And he's saying that that's impossible. Is there anything to that?
Okay, so the question is, in the solar system, if you're looking down from, treat the North Pole of the Earth as being up. Yeah. So if you're above the plane of the ecliptic, looking down on the Earth's North Pole, then the planets are all rotating. Yeah. Well, first of all, they're all revolving around the sun in the same direction. Yeah. They're also spinning in the same direction, except for Venus, which rotates backwards.
Yeah. Even the galaxy rotates in the same direction, right? The Milky Way? No? I'm just...
I'm not sure, actually. I don't remember. I like to focus on planets. They're more local. So Venus rotates backwards, and Uranus kind of rotates backwards in a sense, but actually it rotates sideways. Other planets spin like tops. Uranus rolls along sideways like a ball. So the secular idea for where the planets came from is that there was a cloud of gas that collapsed under gravity that would produce planets spinning like tops all the same direction. Venus rotating backwards, there is a proposed solution to that, I don't think it's a good solution, but it's the one everyone points to. So I don't present that as being a fatal problem for the secular model. Uranus is a problem, though, in that it had to form spinning like a top, and their solution is that, well, something hit it and knocked it over later. That something had to be the size of the Earth. It had to be a really large impact. And that would leave some kind of evidence in Uranus's orbit, but it's not there. Uranus is a nice, stable, very circular orbit. Also, Uranus has a system of moons that orbit the equator. Remember, the equator is pointed up and down, so to speak. So how do all these moons get there? If the moons formed with the planet, which is what the model says should have happened, there's problems with that anyway, but that's what they believe, then you wouldn't, the moons wouldn't move with the planet. They'd all be scattered, disrupted, whatever. Nor can you propose that they formed after the collision. There's other problems with that. And even saying it happened during the collision has a different set of problems. So the moons alone provide real challenges for the whole scenario of Uranus having been knocked over. And there's more to that too. But good question. Thank you.
Why isn't Pluto recognized by some?
Why isn't Pluto recognized?
Yeah. Is it a planet?
It's now called a dwarf planet.
Okay.
And the thing is, so there used to be 9 planets, quote unquote. Pluto is very unusual in several ways. One of the more notable ones is that it's not in the same plane as all the other planets. So if you had the Sun, all the 8 planets have their orbits lining up in a disk shape. Pluto is tilted 17 degrees to all the rest of them. So it is a very strange orbit. And furthermore, at the time that whole debate happened, there was other objects being discovered out in Pluto's neighborhood, so to speak. So if Pluto was going to be a planet, the other objects should have been too, because at the time it was thought one of them was even slightly bigger than Pluto. So we either have 8 planets or like 10, 12, or 13, but not 9 anymore. And there were some other criteria too that people came up with. But yeah, Pluto got demoted, so a lot of people are sad. Yes, David.
When I heard Henry Morris the first time many years ago, he came up with the 2 model theory of trying to explain problems. So if somebody is trying to attack me as a creationist with a problem, he says, you take up a model. If you're a creationist, things should happen this way. If you're an evolutionist, things should happen this way. And you use the model idea. Can you speak about that in all the different areas, including so for the Earth, for instance, we think, if I believe I'm a creationist, I believe that my model is that there was a great flood, and that's why it explains these things. If you're an evolutionist, you believe that it happened some other way. Well, show me your way, and I'll show you my way. See which way is the best. Is that a good way of thinking?
If you're talking to somebody who is well versed in their model, then possibly. If someone is unfamiliar with their own model, then that might not get you very far. It also depends on what's important to the person you're talking to. I mean, I love astronomy, obviously, but most people aren't all that familiar with it. So if I'm talking to someone who has never heard any of this stuff before, I'll start with dinosaurs. And dinosaur soft tissue specifically. Because people... Actually, let me back up. Does everyone know what dinosaur soft tissue refers to? Nope? Awesome. We'll cover that first. Because this is, as much as I hate to admit it, I think this is more important than anything else I've said. Just in terms of how easily understood it is and how important it is. If I remember where I put it. Let's see. So how old are dinosaurs supposed to be? When did the last dinosaur supposedly die out? Millions of years. Anybody know how many million? 65 million years, exactly. I'm in the wrong part of my talk here. Let's see.
Is the next answer Mary Schweitzer?
Yes, Mary Schweitzer is about to be mentioned if I could find the slides. There we go. So a number of years ago, a paleontologist named Dr. Mary Schweitzer, who's not a creationist, by the way, was excavating a tyrannosaur leg bone, the thigh bone of a tyrannosaur. They had to cut the bone in half to get it out of where it was, and noticed something unusual in the middle of this bone. So brought it back to the lab, dissolved away the outer bone matrix of this specimen. Inside of this tyrannosaur thigh bone, found this. soft, stretchy tissue. Emphasis on the stretchy, you see here, right? I mean, beef jerky. Or Tyrannosaur jerky. Is Tyrannosaur jerky going to last millions of years? No. Inside of this tissue, blood vessels and blood cells. This is Tyrannosaur blood in the laboratory. She didn't believe this, and she ran the experiment 17 more times until finally confirmed it, and her apprehension was perhaps understandable because a lot of her colleagues didn't like this either and started questioning her competence. This has subsequently been verified, though. Other people are now looking for soft tissue in dinosaur bones and finding it. It's been there all along, but nobody was looking because we knew it was millions of years old. A more recent example of this is a Triceratops who has this bony shield protecting his neck. A slice of that bone under the microscope looks like this. So you see it's very porous tissue, right? Like bone often is. These pores have this black stuff in them, though. What is the black stuff? The black stuff is coagulated blood. This animal apparently drowned in the mud that it was buried in, and then the mud later turned to stone. Not a normal death. Apparently when an animal drowns, its blood clots a certain way. But zoom in closer under the microscope, and I should mention this fossil was gathered in an unusual way. Usually people just wrap it in plaster or something to protect it. This scientist sprayed a fixative on it first to preserve whatever was there at the moment it was uncovered. Inside of these pores, he found nematodes, roundworms eating the blood clots. Millions of years old? No. Apparently not. Again, other examples of this kind of thing have been found now that people are looking for them. And the secular community is now trying to explain how blood can last millions of years, etc. Their explanations aren't working, by the way. Along with this, people have noted that you can do carbon dating on dinosaur bones and get an answer. That's important because it means there's measurable carbon-14 inside the bones. And that's important because carbon-14 all decays within thousands of years. If you have a sample that's more than 100,000 years old, all the carbon's gone. All the carbon-14 specifically is gone. So if you find carbon-14 in the sample, it's less than 100,000 years old. Dinosaur bones have carbon-14 in them still. Can't be millions of years old. There's also fragments of DNA being found. DNA decays very quickly. It would all be gone after 6.8 million years. Every single base pair would be broken for chemical reasons. Even if you freeze it and seal it off from oxygen, that happens. But dinosaur bones still have fragments of it. And they're supposed to be 10 times as old as the date beyond which DNA would be gone. So lots of evidence for dinosaurs being quite recent rather than older. How did I start talking about soft tissue? So if you're well versed on evidence, that's one possible approach, is to show, well, your model says millions of years, then how then are there worms eating blood clots? How is there carbon-14 in there? Why is there still DNA in there? How is there blood cells in there? That kind of thing. Something wrong with their model. You can also step farther back and show that their model is based on incorrect assumptions about the universe to begin with. The secular model, so for science to even be, I hesitate to mention this because it's a whole rabbit trail, but for science to work, 7 things have to be true about the universe. You have to make 7 assumptions for science to be possible. The Bible affirms all 7 of those assumptions. So if the Bible's true, we can do science and trust that it will work. Atheism, if you take it to its logical conclusion, denies all 7 of those assumptions. So if atheism is true, science shouldn't work at all. Science does work. That denies atheism and supports the biblical worldview. Yes, question?
Did you find that you were ostracized by your peers when you switched?
Was I ostracized by my peers? No. And I was fortunate in that I worked in an environment that was very practical. We were doing space operations, and as long as you did your job well, they didn't really care what you believed. And actually, when I first, after a year trying to disprove all this stuff, finally became convinced it was true, started talking to others about it, and didn't get received. Some people were hostile, which I understood. Other people would say, oh, that's interesting, you're probably right, and then walk away. Like, well, don't you see the implications of this? So that was my clue as a brand new, naive Christian that this isn't a scientific issue. This is a spiritual issue. It's not a matter of facts. It's a matter of your heart and all the rest of it. But to answer your question, I didn't encounter difficulties because I was good at my job and that's all they cared about. Other people working in other environments did. A friend of mine used to work for NASA JPL and got fired because he gave a coworker an intelligent design DVD over a lunch break. So some environments were actively hostile, some were not. I was blessed in the sense that mine was not. Yes?
Do you think they're going to, from the new discoveries of the dinosaurs, do you think they're going to try to clone?
Are they going to try to clone dinosaurs? I don't know if the DNA is sufficiently intact to do that. It would be really cool if they could. But maybe we'll find some bones that have it to that degree. They are trying to clone woolly mammoths. So maybe dinosaurs too someday. I guess we'll find out. Yeah, everyone wants to know, is Jurassic Park going to happen? Yeah. Not yet, but maybe soon. Yes?
Just going back to the Big Bang Theory, is like with the revelations from the James Webb telescope, do they have another respectable opinion, a secular opinion that they follow on? They don't subscribe to the Big Bang Theory. Like, is there something else from the origins of the universe that I guess another secular group that has another theory, like a strong theory that they can pull up that you have to argue or take down?
Not yet. The Big Bang actually wasn't the dominant cosmology until the mid-60s. Before then, it was an idea called the steady state hypothesis, which is that the universe had always been there. But the discovery of the cosmic microwave background radiation discredited that, so everyone went to the Big Bang. Today, the Big Bang is basically the only show in town if you're a secular cosmologist. There's still a few, what they call neo-steady staters left, but they don't get a lot of traction.
How big is the multiverse, people?
Well, the multiverse is part of the Big Bang model now. Because inflation was added to protect the Big Bang from data that would disprove it otherwise. And then later they realized inflation would actually produce a multiverse. Not that inflation is even possible, but if you believe that it is, then you'd have to accept that a multiverse would come out of it too. And then if you have a multiverse, then take their thinking to its logical conclusion, you wind up with aliens simulating universes on their computers, of which we probably are in one of those. I have a whole separate talk on that. But no, that's all part of the Big Bang model. Which is why the multiverse is appearing in popular culture, and which is why a lot of kids are talking about, well, not just kids, some respected scientists are saying we live in a computer simulation. That's driven by some stuff that was added to the Big Bang model to protect it from data that would otherwise disprove it. So, yes?
Like I grew up where the universe has no end, no beginning. It's just nothing forever. How do you have, I don't understand this multi-universe at all. Like if the universe has no end, how do you have a second universe, let alone a million universes?
It's an excellent question. Yeah. Part of it is that they've redefined the term. Universe now means, well, in some contexts, universe now means everything we could possibly perceive, even with the best possible theoretical technology and telescopes and whatever. So from their perspective, there's going to be a large part of reality that's inaccessible to us ever. And so they're now calling that another universe. And long story short, there's a period now in the early Big Bang model where there's this, what's called inflation, where the universe explodes at millions of times faster than the speed of light. Not explodes in terms of breaks apart into pieces, but the universe itself gets bigger at a million times the speed of light. Subsequently, the Big Bang model needs that because otherwise it would be disproved by several categories of data. So to protect the Big Bang from the facts, that was added. Subsequently, it was realized that once inflation starts, it can never stop. And it'll stop in some places locally while continuing in others. So the idea now is that our universe is like one bubble that was spit out by this eternal inflationary process that's been going on forever and will continue to go on forever. So there's all these independent universes that if you're in one of them, you can never perceive the others by definition. And possibly inflation could have produced different bubble universes with different constants or even different laws of physics. So implications of this, first of all, this is mainstream now. Now, if we're in a universe and there's all these other ones that we can never perceive, all those other ones are outside of the natural world that's accessible to us, what word do we use to describe something outside of the natural world? Supernatural, exactly. This is a supernatural explanation by definition. Now, we're told we can't talk about creation because it's supernatural, but yet they're doing the same thing, and that's fine. Okay, I have a whole multiverse talk. I don't want to run down that rabbit trail too far, but yeah, a lot of problems with that. And back?
Not a question, it's more of a comment. It seems like secular scientists are continuing to move the goalposts of their own theories after their own rules are sort of proved to be wrong or inaccurate.
Yes.
Okay, well, no, it's actually 26 billion years. And, or are they going to go, they're just going to keep moving the goalposts rather than admit that there is a creator.
Right. Even the big, an astronomer, Danny Faulkner, some of you know the name, has pointed out the Big Bang model today is not at all like the Big Bang model of 65 when it was first accepted. Because that model didn't have dark matter, didn't have dark energy, didn't have cosmic inflation, didn't have multiverse, didn't have all this other stuff. But yet it's been true the entire time. Just changes constantly. As new things are discovered, we're going to go put another Band-Aid on it. The question about if there's an alternative model, I think a lot of people would like one, because the Big Bang is really starting to groan under the weight of the bandages. And once another one comes along, I think a lot of people are going to jump ship like overnight. We've seen that happen over and over in science. When one theory accumulates too much baggage of contrary observations and someone proposes a new hypothesis that explains it better, and everyone says, okay, forget about that one, we're all going over here. If that happens, incidentally, there's entire Christian ministries dedicated to teaching people we should believe the Big Bang model because it has a beginning of the universe. It's like what happened, they want to be acceptable to the secular community because they believe the secular consensus. What happens when all the secular scientists change their minds? And if you built a whole ministry on that. Yeah, well, if we can get someone else. Yeah, yes?
Yes, does God tell us anything about whether there's life on other, just not on Earth, but on other...
Could there be life on other planets?
Yes.
Not within our solar system, because the other planets are very hostile. But there's other solar systems. Okay, so the Bible doesn't tell us. These are my thoughts, and again, this is my thoughts, not what the Bible says. I don't personally have a problem with life on other planets. I mean, the Lord can create life wherever He wants, as long as the life isn't intelligent. If there's intelligent life on other planets, then there's problems. Because, so there's aliens out there somewhere, intelligent aliens. Are those aliens sinless or sinful? If they're sinless, those are the only two options, right? If they're sinless, they're in a universe that got swept up in a curse placed on the entire universe, according to Romans, because of Adam's sin. So sinless aliens got caught up in a curse that wasn't their fault. That's not fair. Conversely, if they were sinful, then why was the universe not cursed until Adam sinned? So there's problems theologically either way. Jesus became a man, and apparently will remain one. Well, that's not fair to the aliens, especially if they didn't sin. Why are we so special? We rebelled and misbehaved, and so God became one of us. And so there's all these kinds of issues that arise if you say there's intelligent aliens. So life elsewhere, maybe. That would just proclaim the Lord's glory and being able to create whatever He wanted, wherever He wanted. You can ask your pastor about that one. Yes, question.
Yeah. I was just wondering, so if you're having to witness an encounter and to keep it simple, if you find out that they subscribe to the Big Bang, do you think that this is a helpful question? So you could ask them, so do you believe the scientific impossibility that nothing exploded and created everything? Is that, or do you have a better way of questioning their...
Did the universe have a beginning?
Is that a better way to do it?
That's as succinctly as I've been able to boil it down. Because people understand there's only two answers, and then you explore the answers with them and say, well, that violates physics this way. So that's the structure I like. That's just me. If you might think of a better way. So, yeah. Yes, Pastor?
Probably should just take 2 or 3 more questions.
2 or 3 more. Yes?
So, with the evolutionary theory and these discoveries by Mary Schweitzer, has that punched any holes in that as far as they just changed the theories of how long this, soft material or whatever you would call it can exist? Or
They're trying to find mechanisms to preserve soft tissue over long periods of time.
Yeah.
And even on the face of it, a lot of their proposed mechanisms don't make sense. Like they're saying hemoglobin can maybe preserve it, but that's inside the blood. It's not going to preserve the tissues. So I don't think changing the time scale is an option in that circumstance. Because that opens up all sorts of cans of worms about every other creature that's in the fossil record and the age of the rocks and all the rest of it. The Big Bang is flexible enough where we can add 13 billion years and call it good, but they can't do that with geology. So some people are just ignoring it. Those that are paying attention are trying to find a mechanism to preserve soft tissue for millions of years, which, as you can imagine, is a real chore. So, we have time for one more? Yes?
It's just a comment. In 1 Corinthians chapter 2, verse 14.
I'm having trouble hearing you. I'm sorry.
I mean, it's not a question,
Okay.
but a comment. In 1 Corinthians chapter 2, verse 14, in King James Version, the Bible said, a natural man does not understand the things of the Spirit because they are not spiritually discerned. Like all these things we have been hearing, listening to, it takes the Spirit of God to really understand it.
Right.
But a natural man in the world, we argue and counter all that we are saying just because of what they want to do.
Right. Yeah, these things it's science, but at the same time it is spiritually discerned. That if you're not receptive to the things of God, you're not going to want to hear any of this. Yeah, that's certainly true. Well, thank you everyone for having me here. My privilege to speak to you this evening. Thank you.